Okay, so let us continue with Fourier series. So Fourier series, we use the Fourier series to find the solution of the ODE. Find the solution of ODE, just like Laplace. Okay, objective of our learning is about determine the period of the period function. Find the Fourier series of the period function with period 2 pi and 2l. So introduction to the Fourier series. So Fourier series are infinite series design. Okay, infinite series designed to represent the general periodic function in terms of simple one, namely like cosine and sine. Okay, so usually we apply for sine and cosine. They constitute a very important tool, in particular in solving problems that involve ODE and PDE. Okay, ordinary differential equation or partial differential equation. So a function of fx is said to be periodic if its index value are repeated at a regular interval in its domain. So periodic function is normally written as fx is equal to fx plus p, where p is some positive number. This p is called period. Okay, so just like this one. So we have this is fx, this is fx, this is fx, and then if fx and gx has period p, okay, period is referred to this one period. Okay, I have period p and a fx plus b gx with any constant a and b also have the period p. Okay. Okay, so from this, meaning that if we identify the function have a period, okay, have a function have a period. So mostly we deal with sine and cosine, right? So if something like that, okay, is something. I mean, if the function is identified to have a period, so we are able to uh, solve it by using the Fourier series. Okay, Fourier series. So uh, one of the how to say one of the popular formula to for this period uh, function of this Fourier series is earlier formula. Okay, so earlier formula is fx is equal to a0 plus sigma n equal to 1 until infinite of an cos nx plus bn sin nx. So a0 equal to 1 divided by 2 pi integration from minus pi to pi fx dx, and an equal to 1 divided by pi integration from minus pi to pi fx cos nx dx, and bn is equal to 1 divided by pi integration minus pi to pi fx sin nx dx. Okay, so this is the example of the of the period function. So we have cos x, you see that, cos x, so cos 2x, cos 3x, okay, cos 3x, and we have sine here like this, so sine 2x, sine 3x. Okay, so cosine and sine function have the period 2 pi. Okay, so have 2 pi, you can see here. So this is one from here to here, this is 1 pi, this is another one, this is 1 period. Okay, and this one also the same, so from here to here, from here to here, we still have the period 2 pi. Okay, so this is the example 1. Okay, period rectangular wave. Okay, so this is a rectangular wave. This one, this is the function of this equation. Okay, so this function is, you can see from here, f is equal to minus k if x is in between minus pi to 0, and k if between 0 to pi. Okay, you can see from minus pi to 0, so this is minus k, and from 0 to pi we have, this is a k. Okay, so when we have this kind of function so this function occur as external force, so this is the application. External force again acting on a mechanical system, electromotive force in electrocircuit, etc. Okay, just like a switch, you see that, like a switch. For example, let's say it's one, you have one round, one turn, how to say, like one piston rotate like this, so when you rotate one circle, so this is like a spark, one, so when you go down, no spark. Okay, so on and on and on, so this is can be applied. Okay, so the solution from 6a, so this is a 6a equation here. So this is the equation x. Okay, so we have xa, b, and c. Okay, so from 6a we obtain a0 equal to 0. How can a0 to equal to 0? Okay, look at this, our function. So this is x, this is our x, so this is fx, sorry, this is fx. So we have, this is k, this is minus k. Okay, this is k, this is minus k, and then we have this one is 2, minus 2, this is 2, so this is minus 5, sorry, this is 5. So from here to here, from 5, from 0, from minus 5 to 5, so that's the minus. Okay, the function is here, and then from 0 to pi here we got this one. Okay, so if we apply this a0, you can see a0 is equal to 1 divided by 2 pi. Okay, so a0 we got 1 divided by 2 pi. Okay, integration of minus pi until pi fx dx. Correct? So in our case, a0 is equal to, okay, 1 divided by 2 pi. So we this one into 2 minus pi until 0. So we got fx dx, right? And plus from 0 to pi fx dx. Correct? So we will get 1 divided by 2 pi fx dx from minus pi to 0, minus pi to 0 is a minus k, right? So we become minus k from minus pi to 0 minus k dx plus from 0 to pi if fx is equal to k, so this become k dx. Okay, so it will be equal to 1 divided by 2 pi we will get minus k, correct, minus k x, right, minus pi to 0 plus k x 0 to pi. So you will get is equal to 1 divided by 2 pi. This one will be equal to 0 minus 0 will be 0, but minus, so minus will be this one minus, so this is plus, but this is minus again, so become minus k pi, and this one will be 0 or cos 0, so pi will be my plus k pi. You see, this one minus plus plus, so this function will be 0. That's why a0 equal to 0. So this can be seen without integration. If you can see from here is actually fx is equal to 0. Since the area and the 0, so an is equal to, okay, let's see the an. 1 divided by pi 0 minus k constant. Okay, it's easy actually. Okay, you just need to integrate this one, make the integration of this. Okay, I assume you can do it, this one. Okay, so sine, so because sine and x is equal to 0 at minus pi and 0 and pi for all n, similarly, okay, so this one will be 0, all of this will be 0, and then we only have the bn. Okay, so bn is equal to sine here, and then after that we can have cos here. Okay, and then sin cos minus and cos is equal to 1, this yield, okay, 2k divided by 2 pi 1 minus cos n pi. Now cos pi equal to minus 1 cos this one, so cos n pi is equal to minus 1 for odd n and equal to 1 for even n. This is like replace. Okay, we replace this, so cos minus cos pi, if this one is odd number, so we got minus 1. 3 also odd number, right? So this is become 1. But if even number, it become 1 like this. So 1 minus cos 1 minus cos 2n is equal to 2, and this one becomes 0. 2 when it is for odd n, and 0 when it is even n. Then the Fourier coefficient Bn for our function B1 equal to 4k pi, B2 equal to 0, B3 is like this, B4 equal to 0, B5, etc. See, so even number will be 0, but odd number will have a series. Okay, so 4k divided by pi, 3 will be 4k divided by 3, 5 will be 5. Okay, 1. Okay, so we move 4 pi out, so we get sin x plus 1 3 sin 3x 1 5 sin 5x, etc. The partial sum, it's s1. So if you have like, you combine this one, so we got like this, right, and like this and like this. Okay, so this one will be s1, this one will be s2, and this one will be s3, like this, etc. This the graph indicate the conversion of x. Okay, furthermore, assuming that fx is the sum of the series and getting x equal to 2 divided by pi divided by 2, we have f2 pi divided by 2 is equal to k for k pi. So this is become 1 minus 1 3 plus 1 5 minus etc. So this, the whole thing is equal to 5 divided by 4. Okay, so this is result is from this one. Okay, so this is the result from our Fourier series. This is the graph represent that s1 s2 and this is s3. Okay, so we continue this one after we have a break for a while.